Addition and subtraction have a very useful relationship to each other. I'm going to show you how it works with just a couple example numbers. I picked 3 and 2 to start with, so I'm going to take this 3 and I'm going to add 2 to it. 3 plus 2 ends up being 5. If I then subtract 2 from it, that would be like subtracting 5 minus 2. We notice that 3 plus 2 minus 2 is 3, or 5 minus 2 equals 3. And we end up right back at the number that we started with. It's like we never did anything at all. Same thing with subtraction. If I start with subtraction, I do 3 minus 2. That gives me 1. And then if I add 2 to that, we get 1 plus 2, which gives us 3 again. So subtraction and addition, if we do it by the same number, end up undoing each other. Let's take that fact and let's use it over here to solve some simple equations. One-step equations involving addition and subtraction. So we have x plus 6 equals 10. I want to eliminate this 6 and I just added. If I subtract that 6, I want to write this in kind of a different way. Take a look at this 6 minus 6. That ends up being 0. 6 minus 6 is 0. And if I add 0 to any number, it makes no difference to this number. So I'm left with just the x. So we get x equals, and then one very, very important point to keeping equations equal on both sides. If I just subtracted 6 from one side, I need to make sure to do it to the other side, and I get x equals 4. We can keep doing that with these. Subtract 5 to eliminate that, and we get x equals 2. It works with decimals. Subtract 2.1 from both sides, and we end up with x equals 9.9. It works with fractions. I'm going to subtract 5 halves from both sides, subtract 5 halves, and we end up with x equals 5.5, or we could write that as 11 halves. As long as we add and subtract the exact same number, it's going to work this same way. Let's take a look at subtraction. If I subtract 6 and want to undo that, I'm going to just add 6 to both sides. We get x equals 16. Subtract 5, I'm going to undo that by just adding 5 to both sides. We get x equals 12. It works with decimals. We'll just add 2.1 to both sides. So I get x equals 14.1. It works with fractions. I'll just add 5 halves to both sides. And we get x equals 10.5, or we could write that as 21 halves. As long as we pick the same number and subtract and add it, it works the same. There are 2 variations on this that I see throwing people off. So let's take a look at this one. We have a negative number that comes first, but this is addition. A lot of the time I see people that want to subtract 5 from this because they see that addition. Well, if this is a negative 5 minus 5, that ends up being negative 10. And it does not work like we did before. I want to go back to this 0 right here. We can see 6 minus 6 was 0, and that 0 doesn't make a difference. If we take this negative 10, that definitely does make a difference. So this one, we're going to add 5 because negative 5 plus 5 ends up being 0. You might recall that adding a negative number is just like subtraction. So to undo that subtraction, I'm going to add. We'll add 5 to the other side. We get x equals 11. And if I subtract a negative, that's the same thing as adding. So I'm going to rewrite this as x plus 10 equals 19. And if we rewrite that as addition, we now see that we need to subtract 10 from both sides to get x equals 9. Addition and subtraction are inverses of each other. They will be used to eliminate each other in equations for mathematics. Thank you.